Jai Hind dear students, I am Dr. Preeti Mittal and today we are going to have the revision for chapter Chemical Reactions and Equations. It's one of the very interesting chapters of chemistry. From this chapter you will be having one objective type question, one question for 3 marks and one question for 2 marks. So, yes, let's start with the chapter. In this chapter, we will see about the chemical reactions and how we can make out that a chemical reaction has taken place by some changes. Like whenever a chemical reaction takes place, there could be a change in the state of matter. So that the state of matter could change, there should be a change in the color. So maybe the solution can change its color. For example, when copper sulfate reacts with iron, then the blue color of copper sulfate is gone, and that results in a greenish solution because of formation of ferrous sulfate. Displacement reaction takes place there. So whenever a chemical reaction takes place, there could be a change in color. Another thing is the change in temperature. Temperature could change. For example, some reactions are exothermic, that releases out a lot of heat. So in that, change of temperature would be seen. Some are endothermic, in which if you touch the vessel, you will feel that it's colder as compared to the initial what you have taken with. So there could be a change in temperature. And last thing is evolution of a gas. If there a gas is evolving out, then also you can make out that a chemical reaction is going on. This gas could be, if it is carbon dioxide, you can test that the gas coming out is carbon dioxide. If it's hydrogen, then you can make out that hydrogen is coming out because of the, if you bring a burning candle next to it, it will blow off with a pop sound. So you can identify that a chemical reaction is going on by these changes: change in state, color, temperature, and evolution of gas. Okay, apart from that, I'll give you some examples of some chemical reactions. For example, when you burn a magnesium ribbon, you will find that a dazzling white flame is produced. So by the color of the flame you can find out that this chemical change has occurred. Okay, it's important to remember as a 1 marks question also, that what is the color of the flame when you burn a magnesium ribbon. So it's a dazzling white flame. Okay, apart from that, when you're burning a magnesium ribbon, one more question could be there in your exam, that why you need to rub a magnesium ribbon before burning it. So whenever you have to burn a magnesium ribbon, before that you have to rub it with a sandpaper. Sandpaper is a very rough paper. In Hindi we call it as rejmal. Ask your parents, they must be aware what is a rejmal, and you might be having one at home also. So you need to, whenever you have to burn magnesium ribbon, first you have to clean it with sandpaper. Why we have to clean it? Because magnesium is highly reactive. So it reacts with the oxygen present in the atmosphere and forms a layer of magnesium oxide. Now what's the reaction going on? Magnesium combines with oxygen present in atmosphere and forms magnesium oxide. Okay, it's not balanced. I'm going to balance that. In this chapter we are going to learn the balancing also. So magnesium oxide is formed. Now this magnesium oxide layer is formed on that magnesium ribbon. It's a protective layer, and it will not allow this magnesium ribbon to react with further oxygen that we want during burning process. So if we want to burn this magnesium ribbon, first we need to clean and remove this magnesium oxide layer, and then we can burn the magnesium ribbon. Okay, so we need to clean the magnesium ribbon with a sandpaper in order to remove the protective layer of magnesium oxide formed over it, because magnesium reacts with the oxygen present in the atmosphere. Okay, it can come as a 2 marks question. Right? Now the second part is we have to see about the balancing of a chemical reaction. Okay, we will see how to balance a chemical reaction. This is really a very important topic from this chapter for your exams, and it can come as a 3 marks question. You could be given 3 different reactions and you could be asked to balance these reactions. Okay, so pay attention. We will practice few examples of balancing the chemical equations also. Okay, but we are going to practice many such reactions, but at the end of the chapter. Okay, so we are just going to try few balancing of the equations right now and many more at the end of the chapter. Fine. So let's have some practice so that you get an idea how to balance the chemical reaction. For example, sodium sulfate. Now you will be given in words only that sodium sulfate is there. So how to write sodium sulfate? What is the molecular formula of sodium sulfate? For that I have prepared a separate video that how to write a molecular formula. If you haven't gone through that, if you ever make mistake in writing any molecular formula, then just go through that video. It's really very important to write the correct molecular formula. Because if you write the correct molecular formula, then only you are going to balance it correctly. And if you are going to balance it correctly, maybe you will be getting those 3 marks in your exams. Okay, it's a high probability that you could be asked 3 equations to balance in your final exams. Okay, so sodium sulfate when reacts with barium chloride. Now barium chloride is BaCl2. It forms sodium chloride and barium sulfate. Now you have to balance this equation. Okay, you have to balance this equation. Whenever you are asked to balance an equation, you can start with any of the elements that you want. Okay, we have to just check that every type of atom that is there on the right hand side, the number of atoms of that particular atom on right hand side and left hand side should be equal. So if I start from sodium, just see, it's 2 atoms of sodium here and here just 1 atom is there. So to balance that, we need to have 2 molecules of sodium chloride. Now sodium is balanced. Now let's have a look at chlorine. Here we have 1 atom of chlorine in 1 molecule. Since we have taken 2 molecules, so it makes 2 atoms of chlorine here. And here also it's Cl2, so it's already balanced. Now come to barium, it's already balanced. Here also 1, here also 1. Now come to sulfate. Sulfate is here also 1 molecule is there, and SO4 here also 1 ion is only there. So it's already balanced equation. Okay. One more we can practice. For example, hydrogen gas combines with chlorine gas to form hydrochloric acid. Okay, it's very easy one. Here 2 are there, here 2 are there. So we can make it here also 2. 2 atoms of HCl will be formed. Okay, let's try with one more example of balancing of a chemical reaction. For example, iron reacts with steam. Iron is not going to react with water. Iron is going to react with steam, and that is why to show its gaseous state, I am writing G, and it forms Fe3O4, that is known as ferrous oxide, plus hydrogen gas will be liberated out. Okay, since 3 iron atoms are there, let's make this also 3. Since we are having 4 atoms of oxygen here, so it should also be 4. Here also we should be having 4 atoms of oxygen. So to make it 4, I will take 4 molecules of water and 4 molecules of hydrogen will be formed. Okay, so here it will be 4H2. Okay, so I hope this is clear to you all. This is about some reactions that we are practice for balancing of chemical reactions. But we are going to practice many more reactions for balancing. But why at the end? Because by that time we will be learning the types of reaction also. So once we learn the type of reactions and then we are going to balance the equations. So we are going to revise both the topics at the end. For every reaction, we will see its balancing also, and for every reaction, we will also check what type of reaction is it. Okay, so just you can have a look at this. You can take a screenshot if you want. Okay, I hope I can erase this off. Now we'll see the types of chemical reactions. Different types of chemical reactions are there, and one particular reaction could belong to more than one type also. Okay, so we'll see what are the different types of chemical reactions. First chemical reaction that we are going to talk about is combination reaction. You should know the definition of every reaction. Apart from that, you should be more important is to judge whether this given reaction is belonging to combination reaction, or it's a decomposition reaction, it's a displacement reaction, double displacement reaction, or whatever it is. Okay, so you could be given one equation and you could be asked that this reaction belongs to which type of reaction. Okay, so that should be clear to you all. So let's start with that. First is combination reaction. When two reactants combine together to form a single product. Combination, combine हो रहा है. नाम से ही पता चल रहा है that two things are combining together to form a single product. That is combination reaction. For example, carbon reacts with oxygen to form carbon dioxide. है ना, जब भी आप कोल को बर्न करते हो तो ऐसी ही रिएक्शन होती है. कार्बन इज गोइंग टू कंबाइन विद ऑक्सीजन टू फॉर्म कार्बन डाइऑक्साइड. This is one combination reaction. Okay, apart from that, calcium oxide is also known as quicklime. It's called quicklime. It combines with water and forms calcium hydroxide, CaOH whole twice. CaOH whole twice is aqueous. It's dissolved in water. Okay, so quicklime is taken. When we dissolve it in water, then we get calcium hydroxide, that is aqueous, that is dissolved in water. And apart from that, heat is also released in this reaction. Heat is also released in this reaction. And this calcium hydroxide is also known as slag lime. Okay, so this reaction is very important. Okay, this reaction is very important for your exams. I'll let you know why. But before that, I'll tell you something interesting. Nowadays, we are using distemper for whitewashing and everything. Usually, paints and distempers are used. In early days, we used to use calcium oxide. In Hindi, we call it as chuna. Okay, so in early days, people used to get their house whitewashed with chuna, that is quicklime. ठीक है, चूने से पुताई करवाते थे. We used to say it like that. Okay, especially the roof or all. So it was less expensive also as compared to distemper and paint. So it was used for whitewashing. Okay, ask your parents, they must be aware of it. तो ये एक बहुत ही important reaction है. Now what happens in that, let's have a look. This much is for combination reaction. Okay, for combination reaction, this much is over. Now what I'm telling you is apart from combination reaction, but it's given in your NCERT book and it's important as a question also. Okay, so we took calcium oxide, we dissolve it in water, and we got calcium hydroxide. Two reactants combined together to form a single product, so it's a combination reaction. Now what happens next? This calcium hydroxide is painted on your roof, on your walls. Okay, whitewashing के लिए इसको use किया. Now carbon dioxide there in the atmosphere, so it is going to combine with the carbon dioxide present in the room, and that would lead to calcium carbonate being formed and water is formed. This calcium carbonate is having the same formula as that of marble, and that is why it gives a shiny appearance to the walls. So it is sometimes asked in your exams that why a shiny appearance comes on the walls after 2 to 3 days of whitewashing. So why it is after 2 to 3 days of whitewashing? Because calcium hydroxide is used for whitewashing. It combines with carbon dioxide present in the atmosphere and it forms calcium carbonate, which is having a shiny appearance, and that only gives a shiny appearance to the walls. Okay, next, one more thing is there. This calcium carbonate is having the same formula as that of marble, as that of chalk. Okay, one more thing was there that we have already read in the previous chapters, that if carbon dioxide is passed through lime water, this is lime water. Okay, calcium hydroxide is also known as lime water. So we've seen in the earlier reactions also, that in the earlier chapter also, that how we'll find that carbon dioxide gas is released. When carbon dioxide gas is passed through lime water, it turns the lime water milky. Why it turns milky? Because of formation of same calcium carbonate. तो अगर कैल्शियम कार्बोनेट पानी के अंदर बन जाएगा, अपन ने पानी के अंदर ही कार्बन डाइऑक्साइड गैस पास कर दी, लाइम वाटर कंटेनिंग वाटर के अंदर के अपन ने गैस पास कर दी, तो लाइम वाटर पूरा मिल्की हो जाएगा बिकॉज ऑफ फॉर्मेशन ऑफ कैल्शियम कार्बोनेट, and this calcium carbonate is having white precipitate, so that will give the solution a white color. But apart from that, if you continue to pass more carbon dioxide out of it, कैल्शियम कार्बोनेट फॉर्म हो गया, वाटर फॉर्म हो गया, and you are still continuing to pass more carbon dioxide through it, then calcium hydrogen carbonate will be formed, and that is colorless. So that milkiness will disappear. That milkiness is going to disappear. So all these reactions are very, very important. Sometimes you're asked in the question that an substance X is used for whitewashing, and when it is dissolved in water, it forms a substance Y. This Y is used for whitewashing, and this Y after some days forms a product Z on the walls. So what is there? So this X which is used initially is calcium oxide, is usually available in powder form. Then what is formed Y, that is used for whitewashing, that is CaOH whole twice. And when the CaOH whole twice is applied on the walls, after some days, calcium carbonate will be formed on the walls. Okay, so these could be few questions based on this. Now, one more very important thing is that heat is released in this reaction. Apart from that, in this reaction also, heat is released. So, any reaction in which heat is released are known as exothermic reaction. तो हमने कॉम्बिनेशन रिएक्शंस पढ़ने के साथ साथ में एक टाइप की रिएक्शंस और पढ़ ली हैं, दैट इज एक्सोथर्मिक रिएक्शन. एक्सो मतलब बाहर, थर्म मतलब हीट. तो when the heat is being released out, heat is released in a reaction, such a reaction is known as exothermic reaction. Okay, these are not only the examples of exothermic reactions, some more exothermic reactions are there. For example, respiration. Respiration, you all know. When you perform respiration, I'm not talking about breathing, I'm talking about respiration. Respiration means glucose combines with oxygen to form carbon dioxide, water, and heat energy is liberated out, that is stored in the body in the form of ATP. So that respiration is also an example of exothermic reaction. Respiration is also a exothermic reaction. Apart from that, decomposition of vegetable matter. Decomposition of vegetable matter is also an example of exothermic reaction. Decomposition of vegetable matter. Whenever you are forming compost or manure and you leave some vegetable matter to decompose, if you touch that vessel, you will find that the temperature is increased, because that decomposition of vegetable matter is also an exothermic reaction. So in this, we have studied about two types of reaction. One is combination reaction. The second one is exothermic reaction. Every exothermic reaction need not be a combination reaction. Okay, they could exist independently also. You can just take a screenshot if you want. Okay, so I hope you have taken a screenshot. The next type of reaction that we are going to see is just opposite of it, that is decomposition reaction. This was combination reaction. The next type of reaction that we are going to see is decomposition reaction. Decomposition means when one reactant is breaking down to form two or more than two products. That type of a reaction is known as decomposition reaction. Okay, single reactant breaking down into two or more than two products, that is decomposition reaction. Now, let's see about decomposition reaction in detail. This decomposition always requires some energy. These reactions always require some energy. And this energy could be in the form of heat, sunlight, or electric current. Okay. So these decomposition reactions are divided into three categories. Thermal decomposition that requires heat. We'll see some examples. Thermal decomposition. One very important thermal decomposition reaction we are going to talk about is decomposition of lead nitrate. Lead nitrate is PbNO3 whole twice. When it is heated, how you show that it's heated? You can draw a triangle or you can just write heat. Okay. Then what will be formed? Lead oxide is formed. Nitrogen dioxide gas is formed and oxygen is formed. So if you balance that, you will get some reaction like this. Okay. So why is this reaction so important? During decomposition of lead nitrate, a substance, a gas is produced that produces brown fumes. How will you know that this chemical reaction has taken place? Because you will see some brown fumes being emitted out. These brown fumes are due to the formation of nitrogen dioxide, and this makes this reaction very, very important. Okay, so this is an example of thermal decomposition when we are using temperature to have this decomposition, breaking of one reactant to form two or more than two products. So here three products are formed. Okay, one more example of decomposition reaction is when you heat calcium carbonate, then calcium oxide and carbon dioxide are produced. This is also an example of decomposition reaction. Another decomposition reaction is ferrous sulfate, FeSO4. If you take ferrous sulfate and start to heat it, you get ferric oxide, Fe2O3 plus sulfur dioxide gas will be formed, and one more product is formed, that is sulfur trioxide gas is formed. Okay, so if you start heating ferrous sulfate, that is FeSO4, you will get Fe2O3, that is ferric oxide, sulfur dioxide and sulfur trioxide. Okay, we can balance that if we want. Two molecules will be there, SO2, SO3, 4 2s are 8, 3 3 6 7 8. Okay, it's already balanced now. Okay, so this is another example of thermal decomposition reaction. While I'm telling you thermal decomposition of that, I would like to tell you that ferrous sulfate actually doesn't exist like ferrous sulfate like this. Whenever you take ferrous sulfate, in the previous videos we have seen about water of crystallization. So this ferrous sulfate also has some water of crystallization. This ferrous sulfate exists in the form of FeSO4.7H2O. 7 water molecules are there in ferrous sulfate crystals. So if you start heating them, first what will be there? This water of crystallization will be removed. And ferrous sulfate is green in color and it will turn colorless because of this removal of water of crystallization. Then we'll get ferrous sulfate plus water will be separated out, and then when we continue to heat it, then this reaction will be happening. Okay, so this part of the reaction is also given in your book, but it's in the theory part, but as a reaction they have not given it. Okay, but this they have given it as a theory as well as in the reaction also. Okay, so this is a decomposition reaction of iron, ferrous sulfate. Now, one more thing I want to tell you, that in any of the decomposition reactions, you are using heat or some form of energy. So, all decomposition reactions are endothermic in nature. I hope you remember that we have seen that in with combination reactions we have studied some exothermic reactions in which heat was liberated out, and now here we are seeing, along with the decomposition reactions, we are learning about endothermic reactions. Endothermic reactions are those in which heat is or energy is utilized. So in all these reactions you can see heat is utilized, or in any form, if even if electricity is utilized or sunlight is utilized, then also it will be known as a endothermic reaction. You can take a screenshot if you want. Okay, so this we have seen. Now we'll see about electric decomposition. Using electricity, we are going to see some decomposition reactions. So remember, all decomposition reactions are endothermic in nature. Now we'll see about electrodecomposition or electric decomposition, where we are using electricity for decomposition. One very easy example for that is water. When you pass electric current through it, then what will be formed? Hydrogen and oxygen gas will be formed. And this is an example of electric decomposition. Now let's balance that. It should be 2H2O. So two hydrogen atoms will be formed and one oxygen atom will be formed. Now, what type of question, another question that could come in your exam is, if you are performing electric decomposition of water and whatever the gases are coming out, so this is how you can connect that. There's a cork to which you have connected the electrodes. These are inverted test tubes. One of the electrode is connected to the positive terminal and the other electrode is connected to the negative terminal of the battery. Now, when electrolysis will take place, one of the gases will be eliminating at the positive terminal of the battery. That gas will get collected here, and one of the gases will be collected at the negative terminal of the battery, and that particular gas will be collected here. Okay, so hydrogen being positively charged, it will move towards the negative terminal of the battery and will get collected here, and oxygen being negatively charged, it will be collected at the positive terminal of the battery, so it will be collected at the anode. At anode we will see the oxygen gas collected, and at cathode we will find hydrogen gas being collected. Now the question will be not that, the question could be, in which of the two test tubes the amount of gas collected will be more and why? I hope you can guess out. Since you can see here, more hydrogen is formed as compared to oxygen. For every molecule of oxygen formed, there are two molecules of hydrogen being formed in the reaction. And so the quantity of hydrogen will be double as that of oxygen. If this much of oxygen is collected, this much of hydrogen gas will be collected. And so the answer will be hydrogen gas will be collected more, because when we perform the electrolysis of water, for every molecule of oxygen formed, two molecules of hydrogen are being formed. Okay, so I hope that is clear to you. I am going to erase this off now. Now we'll see the last part of decomposition reaction, that is photodecomposition. What is the meaning of the word photo? Photo means sunlight. So the third is photodecomposition, means decomposition in presence of sunlight. This is also very important reaction. Let's have a look. So if we have silver chloride with us, silver chloride has a white color. Okay, it's white in color, and you expose it to sunlight, a gray color substance is formed, and that is silver. Gray colored silver will be formed, and chlorine being gas will be liberated. out. Okay, so we'll balance this reaction. Since two chlorine atoms are formed, here also we have to multiply it with 2. So when you expose white colored silver chloride to sunlight, gray colored silver will be formed and chlorine gas will be just gone into the atmosphere. It will be liberated out. How will come to know about the reaction? Because the white color substance will be changing to gray colored silver. By that we can make out that the reaction is taking place. This reaction is taking place in presence of sunlight, so it is known as photodecomposition reaction. Okay. One more example of photodecomposition reaction is silver bromide undergoing decomposition. Silver bromide is having like similar to that of silver chloride. So again, in presence of sunlight, silver will be formed and bromine will be liberated out in the form of a gas. Both these reactions are used in black and white photography. Okay, developing of a black and white photographs. Right now we just use colored photographs only, but in early days we used to have black and white photography. So for that purpose, for developing of the film of the black and white photographs, these photo decomposition reactions were used. Okay, in the old time movies, if you have ever observed that developing they you could see those developing of the photographic film. So they used to cover everything. The room was totally black, and at one point there was a bright like tube light or some source of light was there, and that was used to develop the photographs. In the old days movies also I have seen that, but you might not have seen that because that was there in old movies only. Okay, so that is used in black and white photography. That's all you need to remember about it. That's all for combination reaction and decomposition reaction. Along with for combination reaction, we have also seen about exothermic reactions, and along with decomposition reaction, we have seen that all decomposition reactions are endothermic reactions. Okay, next type of reactions we'll see in the next video. That's all for today. Good day, everyone.